Okay, so let's look at chapter 3. Chapter 3 is atomic structure and bonding. Okay, now let's see the information here. Atomic structures and the periodic table. So first we learn about the particles in the atom. We call it subatomic particle. So there are proton, neutron and electrons. So these three particles are inside the atom. So proton is positive charge, the mass is 1. So when they say the mass is 1, right, so 1 is actually same mass with hydrogen, okay, same mass with hydrogen, okay, so neutron, 0, the mass is also 1, electron, the charge is -1, and then the mass is 1/1837. So when you look at this mass, you should be able to expect that this is very light and compared to proton, right? So 1837 electrons, 1837 electrons is equal to 1 proton. So you try to imagine how light is the electrons. Okay, now we look at the next point. Proton number of proton in an atom and number of electrons in an atom. Okay, so they said so because in an atom it is neutral. So since it is neutral, protons and the electrons must have the same number so that their charge balance off. Okay, so that's why in an atom the proton and the electrons have the same number. But of course, if they are ions, the proton and the electrons will be different numbers. So basically we can put it into this situation. Okay, so the situation will be, if it's atom, then protons equal to electron. If it's positive ions, proton is more than electron. Negative ion, proton is less than electron. So basically it is something like this. Okay, now let's move on. Nuclear number of protons plus neutrons in an atom. Okay, so nuclear number. Okay, so nuclear number you can see in the periodic table in this particular way. So for example, let's say you have okay, let's say carbon 12 6, carbon 12 6. Okay, so this is the nuclear number. The bottom is the proton number. Okay, so from here we know there are 6 proton, and nuclear number is proton plus neutron. Okay, so because of that, right, you try to imagine we substitute with values. Nuclear number is 12, proton is 6. Then in that case you can find out the number of neutron. So neutron equal to 12 minus 6, neutron equal to 6. So from here we get one idea. To find the number of neutron, number of neutron is equal to nuclear number minus with proton number. So something like that. Okay, now let's move on. Okay, we see this point. In the periodic table, the proton number increases by 1 when you go to the right. Okay, so let's look at the periodic table. We take a quick look. Okay, so I put it here. Okay, we search for IGCSE chemistry data booklet. Okay, so this is A level. Okay, so I change IGCSE Chemistry periodic table. Okay, so this one. Okay, so from here, what we can see, you can see first, in general, the top one is called atomic number. So atomic number is the proton number. The bottom one is relative atomic mass. Relative atomic mass. So we will see this later. The middle one is atomic symbol. Okay, so you can see in the periodic table, the first element is here, hydrogen, 1 proton, 2 proton, lithium 3 protons, beryllium 4 protons. So you see they follow the order of protons. Okay, so from 1 all the way to the greatest one. The greatest one is here, 116. So this is the greatest in our periodic table. So 1 to 116. Okay, most of them are discovered, so except maybe 1 or 2 is not there yet, but it's okay. For the first 20, we have to get ourselves familiar to it. Okay, so now let's move on. Okay, so you see in the periodic table they don't show nuclear number, they show relative atomic mass in states of nuclear number. Okay, so it's okay one. Now let's see in the periodic table the proton number. Yes.
So the RAM, that is the nuclear number lah.
Not really. RAM is not really nuclear number, but sometimes yes, sometimes no. You see, for example, like 1 is the relative atomic mass, and it is nuclear number, which is true. Okay, example again, helium is the relative atomic mass is 4, nuclear number is 4, which is true also. But sometimes it's not true. Let's say, for example, when it's up to chlorine here, nuclear number 35.5, which is not true. So you know, nuclear number cannot take decimal number, so which is not true. But relative atomic mass is okay, is true to take 35.5. Okay, so where in general I have to say that most of them are just nuclear number, except some. Most of the numbers shown at the bottom are nuclear number at the same time, but some not. Some are not, like 35.5, no, it's not nuclear number. So okay.
Okay, sir.
Yeah. Okay, now let's move on. Yeah, let's come back to the notes again. In the periodic table, the proton number increases by 1 when you go to the right. So when you go one element down, you increase proton number by 8 in the first 3 period. Transition elements not included. Okay, let's take a look. They say when you go down the groups, the proton number increased by 8. Okay, let's see whether it's correct or not. Okay, so for example, as you can see here, this is group 1, proton number plus 8, and then plus 8 again. Up to period 3 only. Period 4 is not that way already, you know. It's not that way. So until period 3, it is correct. Not include transition element in period 3. So that means not including this part. This part is not included. This part is not included. So it's just for group 1, group 2. Group 1 is this one. Group 1 until period 3, yes. Group 2 until period 3, yes. So you see the plus 8 to go down to the next one in the same group, plus A, plus A. Okay, and it is also true for all these, so when you go down the group, plus 8. So for example, let's say fluorine plus 8, 17, 9 plus 8, 17, 17 plus 8, oh, seems to be not true already. So it seems to be not true until, okay, so in that case, let us adjust a bit. I cannot circle that big already. Okay, so we can only take up to here only. Up to here. Okay, so you go down the same group, you plus 8. 7 plus 8, 15. 6 plus 8, 14. Okay, so for this only. So after that, not true already. Okay, so that statement is true for the element from the first until 20. 1 to 20 only. Proton number 1 until proton number 20, which is still correct. Okay, so yes.
So generally, going down a group,
Yeah.
The atomic size increases, right?
Yes, atomic size increases, true.
And going across a period, the atomic size decreases.
Decreases, yes. Across the period, decreases. Yeah. Okay, so we will go to that part later. So let's continue first. Okay, now let's see isotopes. Atoms of same element with different number of neutrons. Okay, so that means, for example, carbon 12 and carbon 14. Carbon 12 and carbon 14, so it will be something like this. Carbon 12, carbon 14. Okay, so what we can see here is they have the same proton, which is 6. Same protons, 6. And then, you want to count the neutron, right? So this one, the neutron is 12 minus 6. This one, you want to count the neutron, 14 minus 6, you get 8. So they have different number of neutrons. Same number of protons, different number of neutrons. So they are still known as the same elements, but they are isotopes. So the idea is something like humans, but different masses. Some is fat, so because of that is heavy, and some of them are thin, and because of that they are light. It's something like that. They are the same elements and then different mass. The physical is a little bit different, but the chemistry is the same. Okay, now let's see. Number 2, the next point. 2 types. Non-radioactive isotopes normally refer to the one which is lighter, and radioactive isotopes normally refer to the one which is heavier. So the one which is heavier is normally the radioactive type. So radioactive means they will release some ray or substance like alpha, beta, and gamma. So it has that kind of properties. It will release those particles and ray. And radioactive isotope are unstable atoms, okay, and that break down, giving radiations. So the radiation here is the alpha, beta, gamma that I mentioned just now. So these are the radiation. So of course, this radiation is used in medical, where they use it to treat cancer. So to treat cancer, we have to use this isotope, cobalt 60. Cobalt 60. Cobalt 60. You see periodic table down here again. Cobalt is somewhere here. Cobalt. So cobalt, the relative atomic mass is 59. It's 59. So cobalt 60 is the isotopes, the heavier one. Yeah, the heavier one, 60. Cobalt 60, the heavier one, like what I mentioned, they are normally radioactive. So this is the one. Cobalt 60 is radioactive. It has unstable atoms, unstable nucleus. It gives radiations. So the radiation is used to kill the cancer cell in the cancer patient, and we call it radiotherapy. So the rays kill cancer cells. Okay, and then another application, we applied it in industry, is we use it to check for leaks. So let's say the water pipe leaking happen, so you can use it to check. So what they do is, just imagine, let's say I draw a diagram. This is the water pipe, or any pipe in the machine in industry or in factory, so they are leaking. Okay, so what happened is, let's say the water flow, so leaking happen, and what to do is, let's say this is the water pipe. Okay, so you should expect there are more water around there. So what to do is, you just put some radioactive substance, let it flow around here. So some will leak out together with the water, so some will continue to flow. So the part which leak out together with water will gather up at this particular region in large quantity, and after that you use a gauger counter. Gauger counter is used to detect the radiations. So you use gauger counter to move along to check where's the leaking. So gauger counter will count the radiation. So if the radiation is high, so of course it will be high at this region because there are lots of radioactive substance here. So the gauger counter will count very fast, will show higher readings. So from there, you will know leaking happened at this particular part. So that's why we use radioactive substance. It gives out radiation so that human being can detect which part has higher reading, showing that leaking happens there. So okay, then let's see. The information here, they say we use radioisotopes, which is known as tracers. You add it to the oil or gas at leak. So at this particular part, leaking happened, radiation is detected because we are using gauger counter. So gauger counter will show readings. So the reading here will be high. The reading at all this region will be just normal, but at this particular region will be higher than usual. So now, yes.
First, they put the radioactive isotope first.
Yes, put radioactive isotopes.
So then the thing will collect the water in the place where it is leaking.
Yes, they accumulate there at the place where it leak.
So it's like the radioactive isotope basically don't let the leaked water to spray it lah.
It is still leaking together with the water. So we just need to detect where is the leaking by using this gauger counter.
But it accumulates in one area only.
Yes.
It accumulates the water in one area.
Yeah, in this particular area. So then we have to repair this part. So the part which leak. Okay. Now, so this part we finished already. And let's see the next point. Electrons are arranged in electron shell. Okay. So for example, just now we heard an atom has the same number of protons and electrons. Same number of protons and electrons. So because of that, let's say this one, since these have 6 protons, so we should expect it has 6 electrons also. So carbon has 6 protons, 6 electrons. So we put the electron in shell, something like this. The first shell we put 2 electrons, and we still have 4 more electrons. Altogether 6 electrons, right? So we put another 4. 1, 2, 3, 4. So electron shell look like that. Okay, we fill up the shell with electrons, where the rule is the first shell put 2, the second shell put 8, the third shell put 8 also. Okay, and then you can see here the information is written here. Electron shell structures 2 followed by 8. We use comma. Okay, IGCSE use comma. 2, 8, 8, 18. So first shell, second shell, third shell, and then 18 is the fourth shell. Okay, fourth shell can accommodate 18 electrons. Okay, now let's see more information. Atoms want to have full outer shell, full sets of valence electrons. This is why they react. So they try to explain why chemical reaction happen. Chemical reaction happens so that the atoms will eventually having full sets of valency electrons. Okay, so which means what? So let's say I give one example. Okay, example, let's say sodium. Sodium, if you look at the periodic table, okay, let's see, periodic table. Okay, sodium is here. 11 is shown on top. That means 11 protons. That means 11 electrons. Okay, so remember that sodium has 11 electrons. Okay, now let's continue. Sodium, 11 electrons. Okay, so sodium tends to react, and when it reacts, it tends to form sodium ions. Sodium ions, positive ions. So it becomes positive because it loses one negatively charged electrons. So it becomes 10 electrons. Okay, so let's see the electron shell then. So this is sodium atom. We have 2 followed by 8 followed by 1. Okay, so this is where the outer shell has 1 valence electron. So it reacts, not stable. Okay, it reacts and it loses 1 electron and become 10 electrons. So the electron shell is 2 followed by 8. You know, the second shell, when it takes 8 electrons, it is fully occupied, and this is octet. Okay, octet. Octet is stable. So that is why they want to react. They react so that it becomes stable. That become ion, they become sodium becomes sodium positive ions, but at the end that is stable. Okay, so that's why we have this statement here. Atom want to have full outer shell. This is full outer shell. 8 electron is the full outer shell, or full sets of valency electrons. This is why they react. So how they react? They react by donating 1 electrons to another atom. Okay, so the other atoms is expected to receive electrons. Okay, now let's see. Noble gases have full outer. Yes. Yeah.
Once the sodium ion has already achieved octet electron arrangement, it won't react anymore, right?
Yes, basically yes. So it become octet and it doesn't react anymore. Yeah. Okay. Now it's already stable, and this kind of situation is known as noble gases electron arrangement. So which means what? Which means same electron arrangement like a noble gas. So
which means like inert.
Yeah, inert. Yeah. Okay. So for example, right, this one, this is 2 followed by 8. 2 followed by 8, 10 electron, right? So if we look at the periodic table, 2 followed by 8 is 10. 10 is neon. Yeah. So neon is under the noble gas. Noble gas are here, basically. All these are noble gas. Noble gas. So that means sodium, after reaction, it has the electron arrangement which is same with neon, which is a noble gas, and that is stable. Okay, so now let's come back to noble gas again. So they say noble gases have full outer shells, so they have no need to react. Noble gases, So noble gases, remember, they are at the column on the right, so we call them group 8. You see they use Roman 8, group 8. So we call them group 8. Okay, noble gases is under group 8. They are stable.
Group 18 also.
In IGCSE they use 8, Roman 8.
Oh.
Yeah.
Okay.
Yeah.
So in the exam I have to write group Roman 8.
Yes. Group Roman 8. So something like this. Group Roman 8. So like this. Noble gases, group Roman 8. Yeah, so it's like that. Okay, now let's come back. You can use group 18 for level higher than IGCSE, but for IGCSE, group 8. Okay, so now let's see. Okay, where are we now? Let's continue. Okay, here. Noble gases have full outer shell, so they have no need to react. Noble gases, right? How or why we say full outer shell? Let's see 1 or 2 examples. For example, let's say helium. So helium, as you see 2 on top there, that means 2 electrons. 2 electrons. So helium, right? It has 2 electrons in the first shell, and this is called full. This kind of full is known as duplet. Okay, the first shell can take 2 electrons on it, so that is already full. Okay, now we look at neon. Neon is 10 electron. 10 electron, neon, the shell, 2 electron, followed by 8 electrons. So 8 electrons is full. Okay, second shell can take maximum 8 electrons only. So this kind of full is known as octet. Okay, so what am I trying to say is the group 8, the noble gases, they are either duplet or octet. Okay, so that means all these in green color, all these at the bottom, they are octet. Only the first one is duplet, which is also full. Okay, so since they are full, they don't react. They don't have any chemical reaction as they are full. Okay, so now let's see the next one. Electron shell structures. First shell take 2 maximum. Second shell take 8 maximum. Third shell take 8 electrons maximum. And fourth shell takes 18. More reactive elements have a greater desire to have a full outer shell. So also form more stable compounds. So you see they are trying to give us information like this. If they are more reactive, so who is going to be more reactive? So the one which is very near to octet or duplets are very reactive. So for example, group 1. Group 1 is very near to octet. Group 1, you see group 1, sodium, this is group 1. What is mean by group 1? Group 1 means 1 valence electrons. So group 1 is very near to octet. it's just having one extra electron, and if you remove that electron, it becomes octet already. It's very close to octet. So because of that, they are very reactive. Okay, they are very reactive. Huh? Yeah.
Group 7. Group 7, sir.
Group 7 is also very reactive. Group 7, for example, like fluorine. Fluorine is 9 electrons. 9 electrons. So 2 followed by 7. They are very near to octet also. They are lack of 1 to be octet. So they are very reactive. So when I say very reactive, so it normally refer to group 1 and the group 7. Okay, so they are very reactive. They are lack of 1 to be octet, or need to receive 1 more electron to be octet. So they have a greater desire to have a full outer shell. And once they form compound, they are very stable. Okay, they are very stable. So the more reactive the element, the more stable the compounds form. Okay, so that's the relationship.
So compound is what is compound in this point?
Compound, let's say when 2 elements join up, then they form compounds. So for example, let's say
is it like non-metal with non-metal, or the ion, stuff like that?
It's something like this one. Sodium is one element, fluorine is another element. So now they join up, then they form a compound. So this is the compound.
Okay, it's like something so general now.
Yes. Okay. Metal and non-metal for this case. But not always metal and non-metal. It can be non-metal and non-metal to form compound also. So the idea of compound is different elements joined together. Okay.
It can be non-metal with non-metal also, right?
Yes. Like for example, H2O. H2O is a compound. Why? Because there are 2 elements, at least 2 elements that join up. Okay, so they form compound and very stable. This compound is very stable. Why? Because this one is very reactive, this one is also very reactive, so the compound that form is very stable. So how they form this compound, I think should be easy to see now. This one is going to donate 1 electrons to achieve the octet. So this electron is received by this fluorine, so it's come here. Okay, so I put an arrow here. This electron come here and make this octet. Now both are octet. One is positive charge, another one is negative charge. You know, fluorine, right? After they receive electron, so basically what happened is it become fluoride, which is 10 electron also, which look like this. Okay, let's say one more, I put blue color from sodium. So sodium, positive charge, fluoride, negative charge. You know, positive charge and negative charge, they attract each other, and then they become a very stable compound. Okay, so they attract because of opposite charge, and they form ionic bond, but we learn ionic bond later. So let's just move on first. Okay, now we are going to discuss about the chemical bond. So bonding, the structures of metal. Okay, so we start with element. So just now you heard of elements already. Elements are substances that cannot be split into anything simpler in a chemical reactions. Each element has a unique proton number. So example, elements. So every members here are elements. So for example, hydrogen is an element, helium is an element, lithium is an element, and so on. Okay, so all these are elements. So that's why the periodic table of elements. So they are elements. Okay, so okay, they haven't joined up with others. Once they join up, they may form compound, they may form molecules. Okay, so depends on whether the same types of element are joining or different type of elements are joining. Okay, so if the same type of elements are joining, we call it molecule. Okay, in general. So if different types of elements are joining, then we call it compound. Okay, now let's see. Mixtures.
So
Yes.
like chlorine, because chlorine is always a diatomic molecule, so it is called a molecule.
Yes, chlorine is molecule, Cl2.
But like HCl and all, it's called a compound.
HCl, you can call it compound, you can call it molecule also.
Oh, okay.
So it's also a molecule. So
it's no wrong to put it as molecule also lah.
No wrong. Yeah, it is true. Molecule can be used if there are having covalent bond between the atoms. Covalent bond. So okay. The difference is Cl2 is still element. It's still element. So because they are same type.
How is it possible, sir? Cl2 to have molecule to be called as molecule or element?
The idea for element is there must be the same kind of substance. So there are Cl and Cl. Cl and Cl. Okay, so yeah, and then so it's under element, and HCl is different kind of element. So we have H and Cl that bond chemically, so they are not elements anymore, they form compound. Okay, so now let's see. Mixtures: two or more elements mixed together but not chemically combined. Okay, so that means they don't form chemical bond between the two elements. So examples of mixtures is like, let's say you put sand into water. So the sand mixed with water, but they don't have any chemical reactions. They just mix physically only. Okay, so we call it a mixture. So if there are mixtures, basically we can separate it by filtration. Okay, so compound: substance in which two or more different elements are chemically combined. So that means they're combined by forming a chemical bond. Okay, so how they form chemical bond? Normally we draw a line to represent that. HCl. So this is the chemical bond. Okay, now we are going to learn chemical bonds very soon, so let's move on first. Okay, now we have metal and non-metal. Okay, so let's see the characteristics. Metal strong compared to non-metal brittle. So brittle means it can break down into pieces. Good conductors of heat and electricity. So for example, copper can conduct electricity. It is used in the wire. Poor conductors of heat and electricity. So for example, like let's say oxygen cannot conduct electricity. Okay, so maybe let's say plastic cannot conduct electricity also. Graphite, accept graphite. Graphite is non-metal, but graphite can conduct electricity. So graphite, black color substance. We learn this later in electrochemistry. Okay, so metal, high melting point and boiling point. Non-metal, lower melting point and boiling point than metals. In general, it's true. Of course, we have exception, certain non-metal like diamonds, it has high melting point and boiling point, but in general, we say like this. Okay, so high density. So high density, that means like it sink. When you put them in water, it sink. Low density in general only. Okay, so for example, certain plastic float on the water. In general, so maybe you should think, I think of some non-metal which is kind of dense also, like for example diamond is dense, so of course in general we say it like this. Form of basic oxides, basic oxides form acidic oxides. So example, metal, let's say sodium oxide. Sodium oxide is basic. Non-metal, for example, sulfur dioxide, acidic. Okay, so what else? Carbon dioxide, acidic. When you put them in water, it shows acidic properties. Okay, now next, let's see the next one. Form cations in reactions. Form cation means positive ions. So metal, for example sodium, form sodium positive, this is cation. And then compared to non-metal form anions. So example, let's say fluoride, non-metal. Okay. Malleable means you can knock the metals and it change into a particular shape. So for example, you want to build a car. Okay, so you knock the metal and it form a particular shape of the car. Okay, so that is malleable and it can remain in that shape. Okay, that's the thing. And ductile means you can pull the metals and then you pull it and it becomes wires. Okay, so something like this. You have a piece of metal.
Stretchy laser.
Yeah, stretch and like that. Okay, then the upper layer will go to the left, and then the lower layer will go to the right. So it becomes two pieces of wire, ductile. Okay. Sonorous is where you knock the metal, you will heard the sound like ting like that. Sonorous. Okay, so compared to non-metal, you hear it, the sounds is different, it's not ting, maybe it's different kind of sound, depends on what non-metal. But sonorous, ting, so that is sonorous. Some are magnetic. So some are magnetic. So like iron, steel, cobalt. Okay, so they are magnetic. Nickel. Okay, so magnetic. Okay, now next one. Alloy. Mixtures of two or more metals or mixtures of one or more metal with non-metal to improve its properties. So alloy is where we mix. How you mix? You can mix metal with metals. So for example, steel. Is it steel? Steel is iron and carbon. Okay, steel is metal and non-metal. So metal and metals, for example, the coin that we use. the 20 cent, 50 cent. So it's made of metal with metals. Okay, so why do you have to mix metal with metals? So that it becomes stronger, it becomes harder. Okay, so likewise steel, why you mix iron with carbon? So we want to make steel. Why? Because it's stronger, to avoid rusting, you know. So that's why we make alloy. We mix metal with others. Okay, so we have done everything on this part. Now let's move on. Okay, over here, ions and ionic bonds. Okay, so from here we understand something lah. So ionic bonds, the word ionic, you can see ion there. So ions form ionic bonds. Ions form ionic bonds. So I already gave one example just now. Na plus, which is the positive ion, fluoride, which is the negative ion, then they form NaF. The more common example, Na plus, Cl minus, they form NaCl. Okay, so ions, because of opposite charge that attract each other, that is the ionic bonds. Okay, so chemical bond formed by transfer of electron from one atom to another. So example, sodium 281, one extra electrons here. Not happy with this because you know, not so stable because of these electrons. So transfer the electron to chlorine. You know, chlorine is 287, lack of one to be obtained. So they can't wait to receive these electrons. So they welcome these electrons very much to fill up at this particular position, as you can see here. So sodium, after donating the electrons, it loses electrons and become positive charge. And the chlorine, after receiving electrons, it becomes negative charge. So they have opposite charge and hence attract each other, and that is called ionic bond. Transfer of electron happens here. Transfer of electron is the important words to say about ionic bonds. Important words. So from sodium, the electron transfer to chlorine. So in general, metal lose electrons. For example, sodium is metal. It loses electrons to form cation. Cation means positive ion. Non-metal, chlorine. Chlorine is non-metal. They gain electrons. Gain electrons. So this is the electron gain. And they form anion, which means negative ions. Positive cation and negative anions. Negative anion, no need ions anymore. No? So when you say negative anions, then no need this already. Attract to each other. So attract to each other. So this kind of attraction is called electrostatic force or ionic bond. Ionic bond is what? Is electrostatic force. So electrostatic force is what? Electrostatic force is the opposite charge that attract each other. We call it electrostatic force. They are strong. So strong electrostatic force of attractions between positive cation and negative anion is called ionic bonding. So therefore ionic bonding. Okay, so from here we understand that ionic bond is formed because of the transfer of electrons. So now let's see. Property and reason. Okay, let's see. Form giant lattice. Okay, so what is mean by that? Giant lattice. Giant lattice is like, okay, I show picture lah, faster a bit. Okay, giant lattice. I put it here. NaCl giant lattice. You know, NaCl is sodium chloride. So sodium chloride is like what we discussed just now. They form ionic bond. So how they form giant lattice then? So let's look at the picture. So we can look at this one. So when we say sodium chloride, it's not just one sodium and one chloride. In actual situation, it is many sodiums and many chlorides that interact with each other in this particular way, and this way is called giant lattice. So what happened here is, let's say I start from the middle. You can see red dot in the middle, which is sodium. Sodium is surrounded by chloride in front, at the back, on the left, on the right, up and down. So one sodium ion is surrounded by 6 chloride and ions. And this kind of structures expands throughout the whole lattice. Okay, so which means, like, let's say this chloride ion is also surrounded by 6 sodium ions, one on the left, one on the right which is not drawn, and then up, down, front and back. Okay, so it keep extending, this structure keep extending and become a giant lattice. So that is meant by giant lattice. Okay, so now let's continue. They form giant lattice. Why they form giant lattice? Because the cation and anion attracts. So they attract. So that's why they are like keep building up the structures. And next point, high melting point and boiling point. Okay, why? There are so many ionic bonds. If you look at the giant lattice just now, there are so many ionic bonds. Every line that you see are ionic bonds. So as you can see, let's see it again. So many straight lines over there. The straight line are the ionic bonds. So because of that many ionic bonds, so during melting process or boiling process, we need to break the ionic bond. So many to break, we need a lot of energy. Yeah, so because of that, it has a high melting point and boiling point. So we need a lot of heat energy to break down the ionic bond. So we have strong and many ionic bonds between ions. Don't conduct electricity when solid. Reason: ions can't move. They have to stay in that particular position in the giant lattice. They cannot move. So they are locked by the ionic bond. So ionic bond hold them in that position. Conduct electricity when molten or aqueous. You know, when we say molten, that means melt. The ionic compound melt. Okay, melt. When it melts, right? So that means it is hot. That means we break a lot of ionic bonds, so the ions can move because the ionic bonds are broken. Likewise, aqueous means you put them in water. So once you put them in water, the giant lattice structures is not there anymore. It breaks down because it interact with water. So then the giant lattice structures is not there anymore. It breaks down, and because of that, the ionic bond is not there anymore, and ions can move. Usually soluble in water. Usually only. In general, we say so. Like for example, sodium chloride can dissolve in water.
Usually it is very soluble in water.
Yes. This general statement is just to compare with covalent compound that we will learn later. Yeah. So where we are going to say covalent is insoluble.
Organic solvents, it's not so soluble in organic solvent.
Yes, true. Soluble in water, not soluble in organic solvent. Okay. That is the property of ionic compound. What is the reason? Not required. No need to know the reason. Okay, so it's not in the syllabus.
So
Yeah.
let's say if the molten state of a sodium chloride is always hot. Is it true?
Yes, it is true. You know, you want to make it melt, you need to heat up to a few hundred degrees Celsius.
So what about the aqueous state?
Aqueous is not hot. Aqueous is just mixed with water. It dissolves. You know, sodium chloride mixed with water is like you put salt in water. It's not hot, right? It's just salt water, you know. Yeah, it's not hot. Yeah, so molten is hot. You will see later. They put the molten in a crucible. In electrochemistry, showing that molten is hot. But aqueous they put in beaker. Beaker. We learn that in electrochemistry later. Huh? So now just take it like that first. Okay, let's move on. We have molecules and covalent bonds. So when atoms share electrons, so the important words here is share electrons. So when they share electrons, to obtain a noble gas electron structure. Okay, so obtain a noble gas electron structures. For example, like hydrogens. So hydrogens, when they are single, they are hydrogen with one electron. So the electron shell is like this. Another hydrogens, one electron. Okay, let's say I put a dot to represent the electrons. So they need to share electrons. They cannot transfer electron for this case, because if they transfer electron, one hydrogen has nothing left. Another hydrogen get 2. So that is not possible for H2. So they share. So how they share? They put together. In the middle and share the electron. So that is hydrogen molecule. Okay, so they put the electrons together. So sometimes you may see drawing like this also. Sharing of electrons is drawn in this way. Okay, so or even this way. Sharing of electrons is in this particular way. So this way, or this way. So to show sharing of electron. When they share electron, right? So what happens is they achieve the noble gas electron structures. How? Let's see, you look at the hydrogen on the left. How many electrons it has now? 2. 2 is the duplet. Same with helium. The hydrogen on the right, we count it to has 2 electrons also. So it is noble gas electron structures, which is same with helium. Helium is noble gas, by the way. Okay, so that's how they share. Okay, now covalent bonding takes place between non-metals only. So covalent bonding, they form covalent bond. When they share electrons, they form covalent bonds. So covalent bond is what kind of bond? It's something like this. Try to imagine. Let's say this is hydrogen. The nucleus is here. The nucleus is positively charged, because of the protons. So hydrogen bond is the positive and the negative that attract. So this is the hydrogen. Sorry, this is the covalent bond. Covalent bond is between the nucleus and the shared electron, which is opposite charge. Opposite charge and hence attract, and that is covalent bond.
So covalent bond is between the nucleus of one hydrogen and the shared electron.
Yes, correct. Yeah. So sometimes you can see covalent bond to be single bonds. A single bond, we draw one line. Okay, so single bond is what we discussed here. They share two electrons. They put two electrons in the middle, one from each atom. So that means the first hydrogen give one electrons here to share it, and then another hydrogen give one electron to share it in the middle. So that is one from each atom. Okay. Another example is like chlorine. So let's see, chlorine is Cl 287. Although it has kind of like many electrons here, but it doesn't share all the electrons. It just share one only. How we know it share one? So basically you just need to think like this. It is lack of one to be octet. You know, their ultimate intention is to become octet. To become octet or become duplet, which is stable. So there are lack of one to become octet. And because of that, they will share one with another. So that it become octet at the end. Okay, let's see another chlorine, which is 287 or so. I draw out. I use dot. Okay, something like this. So this chlorine lack of one also. So now they share. So when they share, take the third shell, overlap with the third shell of another one. Okay, so they need one to be octet, then they will share one, you know. So now we see they share the electron there.
Basically, this is also one chlorine shares one electron to the other chlorine.
Yes, correct.
So it forms single bond.
Yeah. So chlorine forms single bond in this case. Yeah, so they share like this. After that, they form the molecule. So it look like this. Okay, so that is single bond. Single bond means share two electrons. Okay, now let's look at double bonds. Double bonds, example, you can see two lines in between, oxygen and oxygen. So when you see double bond, that means 4 electrons share. How we know they form double bonds? Okay, so first you need to look at oxygen in this way. Oxygen is having 6 electrons. So how I know? You have to look at periodic table. Okay, so 6 electron is 2, 4. So 1, 2 followed by 4. Okay, so let's say I put 1, 2, 3, 4. So this is oxygen. So another oxygen, let's say I put in blue color, 6 electron, 2, 8 electrons. 8 electrons, okay, it's a mistake. Okay, right. Eight electron to 6. 8 electrons to 6. Okay, so add 2 more. So another oxygen, same. It's just that I use cross. Okay, so how we know they form double bond? So you just need to think like this. They need how many electrons to become octet? They need 2 electrons to become octet. Octet means having 8 electrons in the second shell. So that is octet. Okay, lack of 2. So if there are lack of 2 to become octet, so basically they will share 2 electrons. So they share it in this particular way. We make the second shell overlap. Okay, then we just draw out. They share 2 electrons. They put 2 in the common regions. Okay, then the rest, okay, remain. Something like this. For another oxygens, like this. Okay, so that is where they form double bond. When they share 2 pairs of electrons, they form double bond. When they share 1 pair of electrons, then they form single bond. Okay, now let's see triple bonds. Triple bond for nitrogens. And nitrogens, they form triple bonds. Triple bond means they share 6 electrons. And how we know nitrogen is able to form triple bond? So you need to know that nitrogen is lack of 3 electrons. Nitrogen is lack of 3 electrons. Nitrogen is having 7 electrons, which is 2, 5. So you need to add 3 more electrons to become octet. Lack of 3 electrons, then they will share 3 pairs of electrons in between. Okay, so lack of 3, then triple bond. Lack of 2, double bond. Lack of 1, then single bond. So we can easily think in that way to understand it. So of course this round I don't draw out because it take time to draw out all this. Okay, now for nitrogens, we just quickly look at the chemical structures. Okay, so nitrogen, electron arrangement. Okay, so this one, 2 followed by 3 in the shared region, another 2 here. So they form these structures. Okay, triple bond. So from there you can see triple bond means 3 pairs of electrons are shared. Okay, so let's continue. Okay, now let's see the properties. Okay, so low melting point and boiling point. So these 3 molecules have low melting point and boiling point. So why? Because they are gas, right? Hydrogen gas, oxygen gas, nitrogen also gas. So that means at room temperature they already melt, they already boil, so that's why they are gas. So why they have low melting point and boiling point? Reason, because they have weak intermolecular forces of attraction between molecules. Okay, so in terms of picture, it's something like this. Let's say hydrogen and hydrogens, so this is H2, this is also H2. So the intermolecular forces is here, and this is weak. The melting process and the boiling process is breaking these intermolecular forces. And this is weak.
So this is like intermolecular forces is also van der Waals forces, right?
Yes, van der Waals forces. Yeah.
Okay.
Yeah. So of course, you may think of, how about the covalent bond here? Covalent bond is not broken. Okay, it's not broken when you melt or boil the covalent substance here. So covalent bond is strong. It is not involved in melting and boiling process. Okay.
So the bond that is attaching the two hydrogen together is covalent bond, whereas the bond between the one hydrogen gas and the other hydrogen gas is van der Waals.
Yes, correct. Yeah. Okay. Now let's
what is intramolecular force?
Intramolecular is this one, the red one, inside the molecule. So this is intra.
It's covalent also lah.
Yeah, covalent.
Okay.
Yeah, intra and inter. Okay, so now let's see the next point. Usually liquid, gas, or low melting point solid. So because it has low melting point and boiling point, right? So that's why they are usually liquid. Liquid, for example, bromine. They are gas. For example, hydrogen, oxygen, nitrogen, they are gas. Or low melting point solid. Low melting point solid, for example, like sulfur. Sulfur, low melting point solid. Okay. Don't conduct electricity. Don't conduct electricity, of course, because there is no ions. You see, they don't form ion. We don't have positive ion, negative ions present here. They are atoms that share electrons. They don't have mobile electrons also. Their electrons are used to form covalent bonds. Cannot move freely. Although you see like here, so many electrons here and there, why they cannot conduct electricity? Because the electrons are held in the shell, cannot freely move. So that's why cannot conduct electricity. Okay, so usually insoluble in water. So this is a general statement. In general, they dissolve in organic solvent. Okay, so reason not required. Okay, so this is the example where the hydrogen atom form hydrogen molecule. So, okay, we have simple molecules so far. From here all the way until here, simple molecule. Okay, so now we have macromolecules. Covalent compound can be, covalent molecules can be simple molecule or macromolecule. So simple molecule is like just two, okay, or maybe three, so they are like very simple structures. Macromolecules is like there are many atoms that join up, many atoms. Okay, so this is macromolecules. Okay, now let's see. So we need to learn three types of macromolecules. They are diamond. So the black dots here are carbon. So these carbons form, each carbon, you see this is carbon. Each carbon form four covalent bonds with other carbon. So 4 bonds. The 4 bonds here is each carbon form 4 bonds. Okay, so high melting point. So why? Because we are yes.
So they basically, each carbon forms a single bond with the other carbon.
Yes, 4 single bond.
Okay.
Yeah. Okay. Then we have a high melting point. Just now the simple molecule, if you still remember, low melting point. Low melting point. Reason, the weak intermolecular forces. But why this is high melting point? Because this one, when you want to melt or boil it, you need to break the covalent bond, which is strong. Covalent bond is strong. So that's why it has high melting point. Okay, so reasonable, right? Diamond has high melting point. Diamond is a solid. Okay, now
So
yeah.
is it like like if they ask why is it high melting point, like is it possible if I say that it is a lattice structure?
It is better to say it covalent bond instead of saying lattice structures.
So for this macromolecule, it has high melting point because the intermolecular bond is a covalent bond.
We better don't say intermolecular bond. We just say
just say covalent.
Just say covalent bond. Covalent bond. Strong covalent bonds. Okay, so diamond has strong covalent bonds. Diamonds has many strong covalent bonds to be broken during melting process. So hence it has high melting point. So is it intermolecular or not? You better don't say that. Okay, so yeah. Now doesn't conduct what? Doesn't conduct electricity or heat. So same reason. No free ions, no ions at all. They are all just atoms. No free electrons. The electrons are used to form covalent bonds. Used for cutting as it is the strongest known substance. So for cutting, cut what? Let's say you want to penetrate through the ground to get petroleum underground. So you can use diamond to cut the ground, penetrate the ground. So graphite. So graphite is also made of carbon, and graphite is like this, the structures. You see it's like a piece of hexagon joined up with other piece of hexagons. So in between this layer and the other layers, you can see some vertical dotted lines. These are the weak intermolecular forces. So it has weak intermolecular forces between one flat sheet with another flat sheet. Okay, so that's why we have weak forces here. So this is the van der Waals forces. Van der Waals forces is weak between the layers. And the other thing is, if you observe one of the carbon, one of the black dot, you will only see they form 3 covalent bonds with others. Okay, so 3 bonds, 3 covalent bonds. Why this one they can form 4, but this one they form 3? So they don't use all the electrons. Okay, you have to know that carbon, right? Carbon has 6 electrons, which is 2, 4. So the 4 here can form 4 covalent bonds. The 4 there is 4 valence electron. The 4 valence electrons can form 4 covalent bonds. But graphite, it doesn't use up all the 4 electrons to form 4 covalent bonds. It just forms 3 covalent bonds. So we still have 1 more electron that remains. And this 1 electron make it conduct electricity. Because it has 1 free electron. 1 free electron. It uses up 3 to form covalent bond, and 1 more is free to move around everywhere they like. So that's why it can conduct electricity. Okay, so and then make of flat sheets. So the structure is flat sheets held together by weak forces, so it is soft and slippery. So that means you can just easily cut through the van der Waals forces or the weak intermolecular forces. Then this piece and this piece is separate, so that is what we call slippery. So it's soft. You can cut in this particular direction. So used as a lubricant. Conduct electricity because it has 1 free electrons. Okay, now silicon dioxide. Silicon dioxide example, sand. Sand is made of silicon dioxide. The black dot is silicon. The red dots are oxygen. The structures look very similar to diamond. It's just that it doesn't have the red dots on it. Okay, so each silicon is bonded to 4 oxygens. Silicon is black dot, oxygen is red dot, and each oxygen is bonded to 2 silicon atoms. So you see one red dot form 2 bonds with the black dot. That is form 2 covalent bonds. It has a high melting point and is hard like diamond. You know, sand is hard, so as hard as not as hard as diamond. A diamond is the hardest. Okay, so the hardness is kind of similar. Okay, now let's see. Yeah, melting point for macromolecule is high. Structures make up of strong covalent bonds. So we break covalent bonds during melting process. Okay, so electrical conductivity. Don't conduct electricity for in general, except graphite. Have no mobile ion or electrons, except for graphite. Graphite has 1 more electron from each carbon, which is free to conduct electricity. The strength, hard, exists in tetrahedral structures. Tetrahedral structures refer to these two. These two are tetrahedral structures. Okay, and then but graphite is soft. So graphite is soft. So the diamond and the silicon dioxide, which is in tetrahedral structures, they are hard, but graphite is soft. Okay, now metallic bonding. Okay, metallic bonding, you can see here positive and negative. So example, let's say sodium is metal, we know that. So sodium, which is 2,8,1, we will change to sodium ion, which is 2,8. 1 electron will come out. So the positive here is like this. It's like a positive metal cation. The negative is the electrons. So there are many sodium ions, imagine, and the electrons around there. So they form this kind of structures. Metal structures look like this. So that means the metal atom will donate its valence electrons to become cations, and then the electrons just move freely around here. So we call it delocalized electrons. So delocalized electron means they are not going to stick to its original master. They are freely moved around the structures. So delocalized electron or free electrons or sea of mobile electrons that can carry charge. Hence, metals are conductor of electricity and heat. The strong electrostatic forces of attraction between the positive metal cations and the delocalized electrons is the metallic bonds. So you see metallic bond, yeah. Yes.
Basically the positive thing is the sodium positive, and then the negative electron is the delocalized electron.
Yes, correct. Yeah.
So basically the delocalized electron is the 1 valence electron.
Yes.
And then the positive is the 2.8.
2.8, yeah. The 2.8 is the sodium positive. Yeah.
Okay. So what I say is correct, right?
Yes, it's correct.
So metallic bonding is between the sodium plus with the valence electron.
Yes, true. So it's something like here and here. So this is the metallic bond. Okay, so again, this is also known as electrostatic forces because it's between positive and negative. So it's known as electrostatic forces. So be careful also. Certain atom like magnesium, they tend to form magnesium 2 plus, and because of that it is going to donate 2 electrons to become delocalized electrons. So in that situation you should expect the metal cation to have a higher charge, and because of that you should expect the metallic bond to be stronger. So it's having a stronger metallic bond if they form a charge of higher value. Okay. So now you see this, the layers are held together by the delocalized electrons. When force is applied, these electrons act like glue, holding the structures in shape. Hence metals are malleable and ductile. So this is the explanation part, why it is malleable and ductile, because the delocalized electrons are holding them in the particular shape. Okay, so like a glue. Okay, so remember these explanations. And then positive ions held together by electrons act like glue. Okay, so this is the explanation that you need to put in the ask. Okay, so we have done the theory part. So it's time to practice. Okay, so the first part of the question, an element M has the electron distribution 2 plus 8 plus 18 plus 3. Which group in the periodic table is element M likely to be in? So what do you think if you see this? So of course you have to know,
Group 3.
Group 3, yes. We look at the last digit, the valence electrons. Okay, so 3 valence electron, group 3. Group 3, Group 3. Roman 3.
But for SPM it will be group 13, right?
Yes, group 13. Now group 3.
Yes, it is. IGCSE is group 3.
Yes.
Okay.
Even if you write group 3, they accept also. They don't accept group 13. Okay, now let's look at B. Predict whether element M is a poor or a good conductor of electricity. Give a reason for your answer. So group 3, So we have to know that group 1, group 2 and group 3, they are metals. They are metals. So metals, they are good conductor of electricity. So we just write good conductor. Okay, now we have to write our reason in short. So you can say
full valence. It needs to achieve the octet something.
Not really because of that reason. Conduct electricity is
delocalized electron.
Yes, delocalized electron. Okay, so it has delocalized electrons. Okay, now we look at part C. Binary compounds contain 2 atoms per molecule. For example, HCl. Okay, so this is binary compound, but binary compound or not really important. So identify an element which could form a binary compound with element M. So
Oxygen.
Element M with oxygen. Oxygen. Cannot, because you see M tends to form 3 plus, oxygen tend to form 2 minus. Then you know we have to exchange the charge. Then the compound form is M2O3. This is 5 atoms. So we want binary. So because of that, right, we have to choose the anion which is from group 5. From group 5, like for example nitrogen, 3 and 3, right? Then you can simplify it to 1 and 1. Okay, then
So can I know if M is gallium, right?
Group 13, yeah, gallium.
Okay.
Yeah, below of aluminium. Yeah. So okay, so Mn. So Mn. Okay. The anion, you must take from group 5. So if you don't want Mn, okay, they want to identify an element, so you can just put N straight away. No need to write the formula Mn. So just put N. If you don't want N, you can choose other element from group 5, for example phosphorus, for example As and SB. Where you look at the periodic table, just take any members, just take any elements from group 5. Okay, so we look at D now. Predict the formula of the sulfates of M. So now we have to use the same idea where we exchange the numbers. So you know M tends to form M3 plus. Sulfate is SO4 2 minus. 3 and 2 exchange. So M2 SO4 3. Okay. Now next one, part E. Okay. The hydroxides of M is a white powder which is insoluble in water. Okay. Describe how you could show that this hydroxide is amphoteric. Okay, so you need to know amphoteric is the compound which can react with acid and it can also react with alkaline. So you must at least say out these 2 important points. Then you will get 2 marks already. Okay, so you just say it would react with we choose an acid with hydrochloric acid. Then you also say it would react with, now we have to choose an alkali, sodium hydroxide. So we settled this already. Now let's just move to the next page and try out the question there. Okay, so this one, let's try this. The table below gives the number of protons, neutrons, and electrons in atoms or ions. Complete the table. The first line is given as an example. You will need to use the periodic table. Okay, so I will put the periodic table on the screen also, so that I can just refer to it easily and you can see it also. Okay, so yeah. Yes?
The 9 is the nucleon number and the 4 is the proton number, am I right?
Okay, hold on, I take a look. I just make this load first, and then I take a quick look.
Okay.
Yeah. Okay, so yeah. Now let me see the 9 and the 4 that you mentioned. Okay, what you said again just now? The 9 is?
The 9 is the nucleon number and the 4 is the proton number.
Ah, yes, correct.
Okay.
Now this one for B, do you know what numbers you put on top and what numbers you put at the bottom?
Yeah, the top has to be the nucleon number, which is 39.
39, okay. 39.
And then the bottom will be 19.
19, yes, correct.
But so why is the electron 18?
If
Isn't it the proton and the electron will have the same number?
Yeah, if they are atoms, yes. So if they are not atoms, then that means this is ion. So ion of what charge?
I think it gives out one electron.
Yeah, give out one electron. Yeah.
Yeah.
Should be positive 1, right? Positive 1. Okay, so 39, 19. You see periodic table. So you can see it here. Okay, so remember our periodic table, the number is like upside down already. So you see we're supposed to write 39 on top, 19 at the bottom, but the periodic table is the other way around. So you must be careful. Potassium. Okay, we write the K and then followed by a positive charge. Positive charge basically because proton is more than electron by 1 unit. Okay, now for C, what number should we put on top?
65, 65 and then 30. It's an atom. So I think it's
30.
chlorine.
65, 30. Okay, so you say chlorine. Let's take a look. 65, 30. Is here. Is this zinc? 65, 30 zinc. Okay, now you think about the charge. Do you think it has any?
There's no charge. It's an atom.
Okay, no charge. It's an atom. Okay, then we look at part D. So part D, we have to add up neutron, proton. So the number on top should be 8 plus 8. Yeah, 16. At the bottom, 8. Okay, so do you know what element is this? 16, 8.
I think it's oxygen.
Yes, oxygen. 16, 8. Okay, so oxygen.
It receives 2 electrons.
Yeah, so you can see electron
it
is
has a charge of 2 negative.
2 negative. Yeah. Okay, receive 2 electrons. There are 2 extra electrons compared to protons. Okay, now the next one for E.
This is the atom.
Yes.
It's 70 for the nuclear number.
70, okay. Nuclear number. Proton number?
Then proton number is 31.
31. Okay, let's see the periodic table. 70, 31.
Gallium.
Gallium, okay. Ga. Okay. Okay, now let's continue the next part. Part B. Using the
Sometimes we copy.
Oh, okay. So I want to copy it first,
Okay, done, sir.
Okay. Using the data in the table, explain how you can determine whether a particle is an atom, a negative ion, or a positive ion. So they give 3 points. So you have to answer 3 of these. So we start with an atom. So how?
The proton number is equal to the electron number.
Okay, yeah. So proton number is okay, but we don't have electron number, so we just call it number of electron. Yeah, number of
Sir, can you give me some time? I need to answer this call.
Okay. So I just write down the answer, then you can just take a look.
Okay, sir.
Yeah. So negative ions, proton number should be less than
Electron.
electrons. Then positive ions.
The electron number is more than
Electron. Proton should be more than.
proton is greater than electron.
Yes. Okay, so like that. Okay, so then consider settle for this chapter.